Dear fellow coders, welcome to One Little Coder. This is day 11 of Kaggle's 30 Days of Machine Learning Challenge. If you are new here, this is the place where I make coding tutorials, specially focused on data science and machine learning. Before we move forward, a quick apologies that there is some work going on nearby my place, so there is a little bit of noise. So in case if you hear some noise, I couldn't do anything about it, so I'm sorry about it. So today's lesson is going to be about actually doing one machine learning competition, which I think we already did in the day 0, the first class, but we'll try to do it slightly more diligently and understand the steps. The first session, I think we just copied and pasted, like we forked the repository. So let's get started. And what have we learned until now? We have learned until now in this machine learning series that what does machine learning? We looked at a simple example of decision tree. Then we looked at model validation, then we looked at what is underfitting and overfitting, and then finally in the last video we looked at random forest, which is like an ensemble model where we build a lot of trees, and then that would also give a lot of accuracy, like better accuracy, I said. And another information is that if you had noticed, I would have also told that random forest is still being used in a lot of industries, companies. So knowing random forest is also mean that you are actually good enough, you are approaching to a level where you are good enough. But building a model is actually the easiest task. There are a lot other things before building a model and after building a model. That's what would make somebody a better data scientist than what you are. So do not always focus only on building models, but you should always focus on other things, like the things that are there before building a model and after building a model as well. So now, after I finish this preamble, let's get started with today's tutorial, which is Kaggle says machine learning competitions are a great way for you to improve your data science skills and measure your progress. I 100% agree. But I would also add one more thing, which is machine learning competition is always good, but you can always start with a Kaggle notebook. I mean, if you have never done anything on Kaggle, so I would suggest you to start with Kaggle notebook. I mean, of course, you can submit your competition scores, results, everything is good, but when you start with Kaggle notebook and the Kaggle notebooks community is really good. So you can make a simple EDA like this, like for example exploratory data analysis. Even you can build a machine learning model. There is no harm in that, like nobody says you shouldn't do that. For example, this notebook, if you look at, so somebody has built a model and also EDA, and then they've got 90% accuracy. That's what I'm trying to show. So you can build a notebook without model, or you can build a notebook with model. But when you do this thing, the thing that you get is you get clarity in communication. You get more people to see your stuff, like you get eyeballs. Like for example, if you consider this person's notebook, it was published 20 hours ago, and then you see 331 views. So at least almost like 300 people have seen this thing. They have got like 11 upwards. So the point that I'm trying to make here is that if you want to get started, I would suggest you strongly get started with notebook section, which is very vibrant. You have a lot of opportunities, a lot of good data sets. But again, this lesson is about competition, so you should do competition as well. But notebooks are amazing. There are a lot of good Kagglers that you can follow to understand how they do storytelling. It's like an art, and how they build models. You can learn best practices about how they are handling their cross validation. All these nuances you can learn from the notebook universe. Okay, now that we know machine learning competitions and notebooks are a great way for you to improve your data science skills and measure progress, let's get started with our first prediction, which is going to be for a competition called housing price competition. So first let's go into the competition and then see what is this competition. So this competition is it's a category called in-class prediction competition. So by doing this competition, you are not going to get any medal or anything. So it's just for your learning, in class learning. So housing price competition is what you are going to wear. You will apply whatever you learned in the machine learning course we just did, decision tree and random forest, and then you are going to actually implement it on a real world data set. Now what is the description? The description is very simple. So there are 79 explanatory variables from MS, Iowa, and what you have to do is you have to actually predict the price. I think, yeah, you have to predict the price. What is the evaluation category? Evaluation category is a metric called root mean squared error, RMSE. So if you have ever learned linear regression, you might have probably learned about this thing, root mean square error. So it is slightly different from what we did in mean absolute error. So you can read more about root mean square error, RMSE, which is basically, if you imagine like you are trying to fit a line and then how much that line deviates from the right value, how much your so it's basically trying to predict how much your answer, what you predicted, deviates from the actual value, and then you took like a root mean square of it. That's it. So it's basically simply that, but you would see a lot of better explanation on the internet for the same thing. So that's what we are going to predict. Why is it important for us to know what metric we are trying to evaluate? So this is very important in terms of Kaggle competitions, where you would be evaluated based on the metric. It is very important in the real world as well, because there could be certain cases where accuracy as a metric could be completely ridiculous. So you might easily get 90% accuracy, but that may not mean anything. So it's very important for you to know when to use what kind of metric. For example, if your data set is highly imbalanced. And what do I mean by that? What do I mean by that is, like, let's say you are trying to train a machine learning model to predict spam or no spam, and 99% of your data is no spam, right? And only 1% of your data is spam. Now when you build a machine learning model, it's ridiculously easy for you to hit 90% accuracy, but does it mean anything? No, it doesn't mean anything. So it's very important for you to understand when to use which evaluation metric. So always pay attention to that. So now that we know this is the competition, let's quickly look at the data set. So the data set, we are given a trained data set and then a test data set. Test data set is how you are going to be evaluated by Kaggle. Trained data set is what we are going to use for us. And because we have trained data set with the target variable and test data set without the target variable, we will split the trained data set itself for our validation data set, and then build the best model and then use it for a test data set. That's what we have done in the past as well. And then it also gives us a text file. This is mostly called as data dictionary in the data world. So if you do not know what this column is, they would try to explain that with the data description text. And then finally a submission.csv file, which will tell us how to do the CSV submission, like what should be the format of CSV, for example. So this is the ID for every ID in the test data set. If you look at test data set, you would see similar ID 1461. So this is basically ID for the test data set, and then the equivalent sales price that you have predicted using your machine learning model. Okay, that's well and good. So now that we know what to do, let's go here and then click create submission, so which will take us to the notebook for us to practice. But before we do that thing, I have not signed into my Kaggle account, so which I have to do. So if you have not signed into your Kaggle account, do that. That's always important. Okay, done. We have successfully signed in. Okay, it's taking me to my dashboard. I don't want that. Let's click the create submission button. That's going to take us to a notebook where we are going to where we will probably get a predefined code already from Kaggle for us to get started. One thing that you should notice is whenever you go to notebook, like whenever you try to create a notebook from a competition interface like this, what we did, you would already get the data set inside. So which means like you don't have to necessarily again import the data. In the sense, like you have the data, this notebook is attached to this data set. You have to import it into your session. That is a different thing altogether, but the data set is already available within your notebook environment. Okay, so now let's start the machine. It's done. Session is getting started. Let's run this meanwhile. What it's basically trying to set up the things that Kaggle for this learning competition that they do, but usually you don't do all these things, like yeah, usually wouldn't do this. Okay, so what are we going to do now? We are going to import helpful libraries, pandas for data manipulation, selecting the columns, splitting, all these kind of stuff. Random forest regressor for this is our machine learning model that we are going to build. We are importing it from scikit-learn's ensemble submodule, and then we have mean absolute error, which is the evaluation metric that we are going to do here. But even though the competition is actually going to use RMSE, we are simply sticking to what we learned. And then train and test split from model selection for cross validation or model validation. Once we have that in place, we are going to take our data set, which is train.csv, and then read into this file path, which is IO file path. This is a string, as you know. So this is a string. Now we are going to do pd.read_csv. PD is the alias in which we read pandas. So we have the data frame here. And then we are extracting the y target variable, and then we are listing down what are the columns that we want, the features that we want, and then we are extracting those features from this and then saving it to x. So at this stage we have y target variable ready, x explanatory variable data ready, and then x of head will show us what is the content of it, And then finally we are going to model validation. So define the random state. I've always said this thing, whenever you deal with anything that involves random numbers, it is very important to set seed or set your random state, so that when you want to replicate this, you can actually replicate this, like you would get the same data when you replicate this. And then when you do train test split, you're going to get 4 objects: train X, validation X, train Y, validation Y. You can use any name, but the names should be meaningful, so that people can understand, okay, this is my train explanatory, this is my train the target variable, this is my validation explanatory, validation target variable. And then we are going to define a random forest model. So we learned also that in scikit-learn the API is quite simple. It's a 4-step process. The first step is define the model, second step is fit the model with your X and Y, the third step is predict with validation dataset, and the fourth step is evaluate it, which means you're going to, whatever evaluation metric that you have used, you're going to evaluate it based on that. And finally print the validation, print the value that you calculated for validation metric. So you know that the validation MAE, mean absolute error, is this one, 21,857. So now in case, like if you want to try instead of mean absolute error, if you want to try, the simplest way is you can just go to Google and then say scikit-learn RMSE. So just search for it, it will probably tell you how to get that. Okay, so it says like, okay, how do I get mean squared error? So you can just get this and then see the example. So it is basically you are doing the same thing, you are doing Y true and Y pred. So how do you import it? You can see, okay, this is how I import it. You can copy, read about it, come back here and probably add it, metrics. So you can either add it as a new line, or you can say mean squared error. So you can do this, you can import 2 like this. And then if you want to also print that, you can say, okay, I want to print MSE, and then I want to say same thing here, which is squared error, just showing you how you can also see. And this is the value, yes. And then you can print, you would get both the values. So these two, like you cannot compare these two values, that's one thing that you need to understand. You cannot basically compare, these are 2 different values, but again, because Kaggle is evaluating based on this, if you want to just see, I'm just showing you how you can just simply take the help of internet and then print the value, that's it. Okay, so now the next thing is the cell above trains a random forest model on train X and train Y, but use the cell below to build a random forest model and train it on X and Y, all of X and Y, not just on train X and Y. So when we would do this thing, when we do hyperparameter tuning, and then when we have the best parameters for random forest, then now we would use that parameters and then train it on the entire X and Y, so we can submit it for our competition, like the test data. But before doing hyperparameter tuning, I think we are already doing that thing. But usually you do hyperparameter tuning, find the best parameters, and then after you get the parameters, you apply it on entire data set. That's the step that you would usually follow. So you have the random forest regressor, which is our RF model, and you can use the same RF underscore model dot fit of X comma Y. So just on that, fit the model on full data, improve accuracy, create which you will train on full data, fit on full data from the training data. Okay, then what do we do? So then we have to predict it on test data. Now we are importing the test data. Now we have to read test data, pd.read underscore csv test data. Okay, and then do we know what columns we want from test data? We know, because we have already created features. So we can just like this, how we extracted like this, we can just say like this, like this, and then say not home data, from test data we can extract test. Okay, and then we have to make predictions. So how do we make predictions? When we make predictions like this, the same model that we fit. Okay, so we have created a model. Where did we create a model? We created a model on full data, and then we can use this. Okay, I think they want us to create it like this. Okay, that's fine. So I can just do like this. We have our model. What is the name that they are calling? I don't know if we have to use the same name. Okay, let's just do what they asked us, not change much. Okay, first step is I'm going to create model, and then I'm going to say fit the model, fit of x comma y. When I run this thing, okay, we have defined the model, and then fit the model. Next is we are going to predict the model. So this is our model name. I'm going to say this dot predict on which I'm going to predict. I'm going to predict on test x, and then when I predict that, I have, this is basically my predictions, test y. Before submitting, just run a check. So you can just run a check, and it's always good to manually look at it also. Like you can go here and then say give me 0 to 10. Okay, so this looks like right, it doesn't look anything wrong. You can check for missing values, whatever you want, you can check all these things. And then finally, now we are going to prepare for a submission. So at this point, we have assumed that we have built a very good model, and then we want to see how the model is going to perform on Kaggle's leaderboard. I'll just quickly go to the leaderboard in some time, explaining you what the leaderboard is. But meanwhile, what we are going to do is we are going to take this test spread, which is currently an array, and then we are going to create a pandas data frame. So we are going to create a pandas data frame. The first column is the column of test data ID. The second column is what we just predicted. So first column's name is ID, second column's name is sale price. Some people do like this. What some people would do is on Kaggle, so they would just simply read sample underscore submission, and then they would take the column name and then assign these values. So which means like you keep the structure intact. So you can do either way. You can either create your own data frame or read the sample submission and then replace the values in that. So you can do either way. And to CSV, which means like you are going to say this output folder, you are going to save the submission, whatever you created, the output data frame as submission CSV. One thing that you need to keep in mind is the sample submission should have only 2 columns. If you do not give the value, the parameter index is equal to false, which means the when pandas writes a new data frame into a CSV, it would add 1 column just like this. Like for example, if I have to print head of output, sorry, if I do this thing, it didn't print, that's a shame. If I do this, you can see the index value here. So we don't want that to be written to the CSV. That's why we say comma index is equal to false. So which is basically us telling that I don't want the index value. And at this step we are good. So we have to go to the submit predictions and do it. But the easiest way, I'll also show you another easiest way, which is once you save the submission, run it, you would get an option. So now our submission is, like our kernel is getting run, Kaggle is running it. So once we do that, we can go to the output page and see the output file. So after this, I'll show you the output file. So if you are here, you have successfully built your first model, and then you're going to enter into the competition and then submit your result to it. So in the next week or in the next classes, we'll learn more about slightly better machine learning techniques. But at this point, I think we are doing good. So let's see how long it takes. Okay, it successfully ran. If I click it, you can see my notebook which I just ran. And then when I go to the last of the notebook, you can also see submit button. So I can either download the CSV, go to the competition page. Okay, first I have to join the competition. First step is, okay, I can submit predictions here. Like I can go do this. I can upload my CSV with a version. I can either do this thing, or what I would do, slightly easiest way is, when you run a kernel like this, notebook like this, you can go here, and here you would get an option to submit. So I would probably prefer this instead of downloading, uploading. Click, and it's basically saying, okay, this is my notebook, this is my output file, this is my version, because we do not have a lot of versions. So this is my first version, description, what I am trying to submit. We can add more meaningful data. So we can say this is a random forest with no tuning. So you can say baseline, like this is like your first model. Okay, submit it. Okay, submitting might take a little bit of time, so you can check your status on my submissions. Go to my submissions. So your submission, just now you submitted, it is done. Your score is probably this, and then you can go to the leaderboard and then see where you stand. Okay, I stand as 9744th rank. That is good. A lot of people have submitted. Okay, so we have completed the entire process at this point. where we have managed to build a model, submit for a competition. So quickly I would like to talk about Kaggle's leaderboard, because if you're going to submit more competitions, you need to know this thing. So what is leaderboard? Leaderboard is the place where you're going to see where you stand in terms of your model prediction. Good, right? That's very well, good. But you would see two leaderboards. One is a public leaderboard, the second is a private leaderboard. Now, what is a public leaderboard? What is a private leaderboard? Kaggle has tried to explain it here. So this leaderboard is calculated with approximately 50% of the test data. The final results will be based on the other 50% of the test data. So the final standings might differ. So the final standings is where you see on private leaderboard. So if you see any recently completed competition, you would see a public leaderboard, you would see a private leaderboard. Okay, so whatever score that you are getting here, it is based on the 50% of test data. So the rest of the 50% Kaggle has not shown it to you. You cannot do anything about it. So when you submit something, imagine now your model is going to overfit for your test data as well. You have not done anything cross validation, you have not done anything. So your model might look so awesome on your public leaderboard. You might even hit the top 10, top 20, whatever it is. But when it comes to the competition end, when the private leaderboard evaluation is going to happen, your model might do one of the poorest models, because the 50% of the data might be different from what the other 50% is. So if your model doesn't generalize well, if your model is overfitting, so you would get probably very terrible result. So that is what public leaderboard and private leaderboard is. So it's always important not just continuously be behind the score, but also keep your cross validation in mind, so that the score that you are getting here on Kaggle, whether it is similar to the score that you are getting. So that's one of the reasons why we actually manually check cross validation for our validation data set. So okay, my validation data set score and this score is close enough, so that I'm not basically overfitting. Imagine your own validation data set score is very low, and then this score, probably the error, in terms of error, if it is very high or the otherwise, so which means you are either underfitting or overfitting, so you would have a terrible performance in the private leaderboard. So that is something that you need to keep in mind. So just to give you quick sense of the leaderboard change, I would like to show you a competition that recently finished. Recently closing soon. Okay, this is all recently launched competition. Let's go to a competition that happened 2 years ago. So let's go to the leaderboard. If you see the public leaderboard, you would see a lot. And when you see the private leaderboard, you would see these small icons that says, for example, if you see this person, big data is cool. This team, if you see, this came down 12 points from public leaderboard. So mostly on public leaderboard, if you see big data is cool, they are on the 22nd position. But on private leaderboard, they have dropped down to 34th position. And for example, this team, if you see, they have jumped up 13 position. So these things happen primarily because they didn't take care of their cross validation very seriously. That also means that this kind of shakeup is quite common. So that's why you should always, there's a saying that you should always trust your cross validation more than what score that you get. So like now you know how to optimize. You are not madly optimizing. And if you see this competition, the public leaderboard is only based on 25% of test data. The private leaderboard is based on 75% of test data. So you know how much difference it is. So it's always important to do good cross validation, so you can actually build a good model that does well on both public and private leaderboard. So congratulations, you have successfully built your first machine learning model, that too random forest, and then submitted to a Kaggle competition. So it's something to celebrate. And if you have any questions, please let me know in the comment section. Otherwise, I'll see you in the next videos.